From the dawn of humanity, we have gazed up at the night sky, wondering about our place in the cosmos. Among these celestial wonders, one object has held a particular fascination for us: Mars. Our planetary neighbor, a reddish hue in the darkness, has long been associated with war, mystery, and the possibility of life beyond Earth. Early observers noted polar ice caps that waxed and waned with the Martian seasons. In the 20th century, science fiction writers fueled our imaginations with tales of Martian invaders and strange alien landscapes. With the launch of Sputnik in 1957, humanity entered a new era of exploration. Early robotic missions sent back the first glimpses of the Martian surface, revealing a world of desolate beauty. Orbiters mapped the planet in exquisite detail, showing signs of ancient rivers, lake beds, and possible ocean basins. It became clear that Mars was not always the arid wasteland we see today. The question that now gripped scientists was, did life ever exist on Mars?
The evidence for Mars's watery past is written across its face, a story told in the language of geology. Giant channels, some stretching thousands of miles, carved through the Martian plains, hinting at catastrophic events. Dried riverbeds suggest a climate that was once warmer and wetter.
The discovery of these ancient water features painted a picture of a planet that was once far more Earth-like than we had imagined.
The Martian riverbeds are time capsules, preserving within their sediments the geological history of a lost world. Some riverbeds are small and narrow, while others are vast and complex, suggesting a range of climatic conditions.
The sediments themselves are a treasure trove of information. Their composition and the presence of specific minerals can reveal much about the environment in which they were deposited. For example, the presence of clay minerals provides strong evidence that liquid water once flowed through these ancient channels. The evidence for a vast ancient ocean on Mars is perhaps the most compelling and controversial of all. Scientists point to features that suggest the presence of a vast northern ocean on early Mars. These include ancient shorelines and the smoother lower northern plains. Martian meteorites contain minerals that form in the presence of salt water, suggesting Mars may have once had a salty ocean. However, the exact extent and duration of this hypothetical ocean remain subjects of debate. The discovery of evidence for past liquid water on Mars was a game-changer in the search for extraterrestrial life.
Intriguingly, Mars possesses all the ingredients for life: water, energy, and the right chemical building blocks. Martian meteorites have been found to contain organic molecules, the building blocks of life. The question of whether these ingredients ever came together to spark the flame of life remains one of the most profound mysteries of our time.
The year is 1996. NASA scientists unveil a discovery that sends shockwaves through the scientific community. A meteorite from Mars designated ALH 84001.
This meteorite held within its crystalline structure a story from a time when Mars was young. Scientists discovered microscopic structures resembling fossilized bacteria within the meteorite.
The implications were staggering. If these structures were indeed fossilized Martian microbes, it would mean that life had existed on another planet. It would rewrite our understanding of our place in the cosmos.
The scientific community approached the findings with cautious optimism and skepticism.
The fossil-like structures were incredibly small, pushing the limits of what could be resolved with microscopes. Skeptics argued that the structures could be explained by non-biological processes. The debate highlighted the challenges in searching for signs of ancient life on other planets.
Despite the ongoing debate, the discovery of ALH 84001 had a profound impact on the search for life on Mars. Scientists developed new technologies and techniques for detecting biosignatures.
The search for life beyond Earth is a complex endeavor requiring rigorous scientific inquiry and open minds. The story of ALH 84001 continues to inspire new generations of scientists and dreamers. The discovery of ALH 84001 had an undeniable impact on the search for life beyond Earth. It served as a powerful reminder that the universe holds many secrets. The search for life on Mars had become a tangible, achievable goal. The discovery of ALH 84001 rekindled our sense of wonder and set the stage for a new era of exploration. The dawn of the 21st century marked a turning point in our exploration of Mars.
A new generation of robotic explorers, more sophisticated and capable than their predecessors, were dispatched to the Red Planet.
Among these pioneers were the Mars exploration rovers Spirit and Opportunity, which landed in 2004. These twin rovers found compelling evidence that Mars was once much warmer and wetter than it is today.
But it was the arrival of Curiosity in 2012 that truly ushered in a new era of Martian exploration.
As Curiosity explored Jezero Crater, scientists planned an even more ambitious mission centered around a new rover named Perseverance.
Perseverance targeted Jezero Crater, a location that held great promise for finding signs of ancient life.
Jezero Crater was once home to a lake, indicated by a well-preserved delta. Lakes on Earth are teeming with life. Could the ancient lake in Jezero Crater have harbored life?
These questions drove the Perseverance mission, potentially rewriting our understanding of life in the universe.
Perseverance, equipped with even more advanced instruments than Curiosity, touched down on the surface of Jezero Crater in February 2021. Its mission, to search for signs of ancient life, collect rock and soil samples for eventual return to Earth, and pave the way for future human exploration of Mars.
The rover's instruments were specifically designed to detect biosignatures, the telltale signs that life may have once existed. These biosignatures could take many forms, from fossilized microbes to organic molecules preserved in the rocks.
Perseverance's cameras, capable of capturing images in stunning detail, would search for macroscopic signs of life, such as stromatolites, layered structures formed by colonies of microbes.
Other instruments, such as the rover spectrometers, would analyze the chemical composition of rocks and soil, searching for organic molecules, the building blocks of life. These molecules, while not definitive proof of life, would provide strong evidence that the conditions for life may have once existed in Jezero Crater.
One of the most groundbreaking aspects of the Perseverance mission is its role in the Mars Sample Return Campaign, a multi-mission effort to bring Martian samples back to Earth for detailed analysis.
Perseverance, using its drill, would collect rock and soil samples, sealing them in special tubes designed to protect them from contamination. These tubes would be left on the Martian surface, awaiting retrieval by a future mission.
Once back on Earth, these pristine samples would be subjected to a battery of tests and analyses that would be impossible to conduct on Mars. Scientists, using the most sophisticated instruments available, would be able to study the samples in excruciating detail, searching for even the faintest traces of ancient life.
The Mars Sample Return Campaign is a testament to the collaborative spirit of space exploration, involving multiple space agencies and countless scientists and engineers from around the world. It is a mission driven by the fundamental human desire to understand our place in the universe, to answer the age-old question, are we alone?
The samples collected by Perseverance, once returned to Earth, hold the potential to unlock some of the greatest mysteries of our solar system and perhaps even reveal the existence of life beyond our own planet.
As robotic emissaries like Curiosity and Perseverance diligently scoured the Martian surface, meticulously piecing together the history of a once watery world, a different kind of mystery was brewing in the thin Martian air.
It began with faint whispers, fleeting signals detected by orbiting spacecraft and telescopes on Earth. These signals, subtle but persistent, hinted at the presence of a gas in the Martian atmosphere, a gas that had no business being there unless something somewhere was actively producing it: methane.
Methane, a simple molecule consisting of one carbon atom bonded to 4 hydrogen atoms, is no stranger to Earth. It is the primary component of natural gas, a fossil fuel formed over millions of years from the decomposition of organic matter.
On our planet, methane is primarily a biological product released by a vast and diverse array of life forms, from microscopic bacteria in the depths of the oceans to the ruminant animals that graze our pastures.
The discovery of methane on Mars sent ripples of excitement and intrigue through the scientific community. Could this be a sign of life? A telltale exhalation from Martian microbes hidden beneath the surface? Or were there other, more mundane explanations for the presence of this enigmatic gas?
The race was on to unravel the mystery of Martian methane, a mystery that would challenge our assumptions, push the boundaries of our understanding, and lead us down unexpected paths in our search for life beyond Earth.
The initial detections of methane on Mars were met with a mixture of excitement and caution. The signals were faint, often near the limits of detection, and the concentrations of methane observed were extremely low, far lower than what would be expected if life were the primary source.
Moreover, the methane seemed to appear and disappear in unpredictable ways, sometimes vanishing entirely for months or even years, before reappearing just as mysteriously.
Scientists, ever the skeptics, were quick to point out that methane could also be produced by non-biological processes, such as volcanic activity or the interaction of water with certain types of rocks. Mars, while not as geologically active as Earth, still harbors volcanoes, some of which may still be dormant rather than extinct.
The release of methane from these volcanoes, either through eruptions or through slow seepage from vents and fissures, could potentially explain the observed methane signals.
Another possibility was that the methane was ancient, trapped beneath the surface for billions of years and slowly seeping out through cracks and fissures in the Martian crust. This methane, produced long ago by geological processes or perhaps even by early life forms, could be released in episodic bursts, explaining the observed fluctuations in methane levels.
The challenge for scientists was to tease apart these various possibilities, to determine whether the methane on Mars was a sign of present-day life, a relic of a bygone era, or simply a product of the planet's ongoing geological activity.
The idea that life might exist beneath the surface of Mars, shielded from the harsh radiation and frigid temperatures that prevail above, has long captivated scientists.
The discovery of methane, a potential biosignature, added fuel to this speculation. Could there be Martian microbes hidden in the porous rocks beneath the surface, eking out a living and releasing methane as a byproduct of their metabolism?
On Earth, such subsurface ecosystems, known as deep biospheres, are surprisingly common. Microbes thriving in the absence of sunlight have been found in deep mines, at the bottom of the ocean, and even within the solid rock of the Earth's crust.
These organisms, often referred to as extremophiles, have adapted to survive in environments that would be lethal to most other life forms.
If life ever existed on Mars, it's possible that it too retreated underground as the planet's surface became increasingly hostile. The discovery of methane, especially if it could be linked to specific locations or geological features, could provide valuable clues in the search for these hypothetical subsurface life forms.
Scientists, using a combination of remote sensing data, computer models, and perhaps even future missions designed to explore the Martian underground, are actively investigating the possibility of a deep biosphere on Mars, a hidden realm where life may have found a way to persist against all odds.
The mystery of Martian methane is a testament to the complexity of our solar system. It could be a sign of extant life or ongoing geological processes.
Future missions will continue to monitor the Martian atmosphere, searching for signs of active geological processes or subsurface life.
The story of Martian methane reminds us that the universe is full of surprises. Are we alone? Is there life beyond Earth?
The quest to unravel the mysteries of Mars, to determine whether life ever flickered on its surface or still lingers in hidden recesses, is far from over. Each mission, each tantalizing clue, fuels our determination to delve deeper, to push the boundaries of our technological prowess, and venture further into the unknown. The coming decades promise a new era of Martian exploration, one marked by even bolder missions and the potential for groundbreaking discoveries.
The Mars Sample Return Campaign, a testament to international collaboration and scientific ambition, will be a pivotal chapter in this ongoing saga. The samples meticulously collected by Perseverance, once safely back on Earth, will be scrutinized with an intensity and rigor unmatched in the history of planetary science. Laboratories around the world will become temporary homes to these Martian envoys, as scientists, armed with cutting-edge instruments, search for the subtle signatures of past life, for the chemical whispers of a bygone biosphere.
But our robotic emissaries, as capable as they are, can only take us so far. The dream of sending humans to Mars, once the stuff of science fiction, has become an increasingly tangible goal, a testament to the boundless potential of human ingenuity and our innate desire to explore. The footprints of astronauts etched into the rusty soil of another world will mark a profound turning point in human history, a moment that will redefine our place in the cosmos. Imagine a time not so far in the future when the faint glow of a distant spacecraft heralds the arrival of the first human explorers on the red planet. Imagine the awe and wonder they will feel as they gaze upon the desolate beauty of this alien world.
Human explorers will usher in a new era of Martian exploration, characterized by a level of detail and understanding that robotic missions can only dream of achieving. They will traverse the Martian landscape, exploring canyons and craters, collecting samples and deploying instruments with a dexterity and intuition that no robot can match. The search for ancient life on Mars is more than just a scientific endeavor. It's a profound journey of self-discovery. It's about unraveling the story of our solar system, tracing the threads of cosmic history. The evidence we seek has the power to reshape our understanding of life's place in the universe. Discovering life on Mars would be a paradigm shift for humanity. It would suggest that life is woven into the very fabric of the cosmos. Such a discovery would ignite our imaginations, fueling a new era of exploration.